Imagine that you want to take different actions based on the type of drive that the user has selected. So you could use code like this to do that. Okay, prompting for a drive letter, waiting until the user enters a drive and pressing enter, checking to see if the value is null or empty, and then using the drive info class in order to get information about the drive. Then I want to test various related conditions. So if the drive type is a CD-ROM, I want to write that out to the console. If it's a fixed disk, write out that it's a hard drive. If it's a network drive, removable and unknown. And if just none of those apply, then the failsafe else is going to just display what's up with this drive. Okay? Don't you love sassy software? So this code, a little bit hard to read. The indenting is good, and it's formatted about as well as it can be. The syntax highlighting within Visual Studio helps your eye to identify. You can go directly to the brown, to the brown, to the brown to see the different options there. Make sure that you've gotten them all right, and so forth. But it's still kind of hard to read. Involves a lot of repetitive typing as well. So instead of comparing the condition to each individual value like that, you can simplify the code using the switch statement. And here's that code rewritten like this. Now it's a little bit longer, but that's mostly because I have additional blank lines in here that I didn't have in the previous code. I could include those in the previous code. But anyway, the syntax is much simpler and cleaner. So what the switch statement does is it lets you select from multiple values for the same condition without needing to provide those nested if statements. So basically I'm doing the same thing as the previous method. I'm prompting the user to enter a drive letter, checking if it's null or empty, getting the information, and then using the switch statement right there in order to compare multiple different values to this drive type value. So in essence, if I come back up here, here's the info.drive type. So that's the value that I'm using as the value for the switch statement itself. And then it's these values over here, the different enumerated values of the drive type enum. It's just a type of variable that lists multiple alternative values. So it's using this property that can be any of those values and then comparing it one by one to each of the possible values. All right, so if it is a CD-ROM drive, it's going to execute the same console.write line as I used in the previous code. Now, one of the big things that's different is that for each of these, I have a break statement right here. This causes C# to jump out of the switch statement and to execute the line of code immediately following the switch statement. So in this case, the switch is there. That's the closing bracket of the switch statement. I really like Visual Studio's bracket matching. So I can highlight, I put the cursor actually right after that statement and it highlights the matching one. So this statement, not really a statement, but closing bracket immediately after the switch would be here. And I could have additional code here. So if this line executes, because it is a CD-ROM, it'll execute the break method and execution will jump right there. Now, if you don't include a break statement in any of the case statements, then C# will fall through to the next case. So code will continue executing with this case right here. So it's normally fairly important to include the break statements, but I'll talk about sometimes when it's not necessary. And you can create some very sophisticated switch statements by selectively including and excluding the break statement. Now, unlike C and C++, if you have any experience with those programming languages, in C# you can't fall through a case statement unless the case statement includes no code. So another way of saying that is that if a case statement includes code, you can't fall through to the next case. So in that case, leaving out the break statement is going to cause a compiler error. So if I had left out this one right there, and because I have code there, then if I leave that out, the compiler is going to complain. Now, in some ways, this makes the case or the switch statement a little bit less flexible than its cousin in C and C++. But it also prevents an awful lot of bugs that are hard to find, hard to see, really hard to track down unless you very meticulously identify exactly the conditions that cause it and then trace through the code very, very carefully. So this is another way where C#'s being a little bit conservative, but probably more than 99% of the time, you'll be glad that it does. Again, I'm projecting a bit there from my own mistakes over the years. Okay, unlike C and C++, in C# you can use a string literal as the value that your switch statement compares against. So instead of a variable here, I can use a literal string value and then have maybe different method calls that produce a string, that return a string that is then compared to the switch to identify if this case statement is going to be the one that's executed or that one or whichever one. Now, if you need to include a statement in a case, but then want to execute another case, and you can't simply fall through because you've added code to the case, then you can use the goTo statement to explicitly branch to the case. Yes, dirty little secret, C# has a goTo statement. There are situations where it's necessary. They're very rare, and most of the time you can improve on your code by rewriting it, but it does have a goTo statement. Okay, and then if none of the case statements match this value here, then if you include it, the default case is going to execute. So this is the fail-safe case. Okay, so let me go ahead and run this code, show you that it works. And I'll hit H to test that, enter C as the drive letter, and it is in fact a hard drive. Hit H again and enter J. Okay, can't find it, and so it falls through to that default case. All right, so that's how the switch statement works, basically. So here I have another method that kind of explores some of those issues with the switch statement a little bit more. Okay, and actually I'm going to run this code first, just to show you what it does. Press I, enter a number less than 21, I'll enter 5. I entered a small prime number. I again, I'll enter 2. Entered a small prime number again. Cool. I again, I'll enter 4 this time. That's definitely not a small prime number. Okay, that time I entered an even number. This time I'll enter 67. Definitely love going outside the bounds. Number out of range. Okay, so obviously what's happening here is this is some code that looks at the characteristics of numbers that I type in within a particular range and gives me some information about it. And it uses a switch statement in order to handle this. Okay, so I'll exit out of that. So here's the code. So I prompt the user for a number less than 21, and here's the number. So I'm going to set a default value for the number type. This is the string that I'm going to use in order to identify the type of number this is. I try to parse the number. If it's successful parsing, then it's going to be placed in that number. If I scroll down here, you can see that I don't have any else statement, so it's just going to skip over executing this code entirely. But assuming I did enter a number, then it checks to see if the number is greater than 20 or the number is less than 0, and it gives me that number out of range. Okay, so there I've got a number, it's in the right range, and now we need to investigate the characteristics of the number. So I use the number variable as the switch variable. And here I have two cases where I fall through to a common result. So if the case is either 0 or 1, if it's 0, it's going to come in here. Oh, we have a match. There's no code there. Because there's no code here, I don't need to include a break statement, so I don't get a compile error. It falls through to case 1. If I entered a 1, it sees, okay, I'm matching this case right here. It's going to execute this code. So that's how it works to fall through different cases. Again, this only works because I didn't include any code for case 0. And here's an extended example of that. So all of these fall through to common result. So if I come in, I enter 5, it sees, okay, I have a match there. It's going to fall through until it finds some code to execute. So it's going to do that for 2, 3, 5, 7, 11, 13, and so forth. And it says I entered a small prime number. And that's the result that we got several times. Okay, so here's another example where it falls through for either 9 or 15. It executes this line of code. But then, rather than executing a break statement, because I don't want to break and jump out of the switch statement, because all I've done is assigned a value to a number type, I'm going to execute the default case, which is going to write a line that says that I selected an odd or an even number. Now, remember that I initialized number type to even. So that's why if I don't match any of these other cases, number type is going to be even, and it's going to say you selected an even number. But here, if it's 9 or 15, it's going to change that value to odd and then write that out. Now, I have to admit, this is a little bit weird. There's obviously other odd numbers, but the priority is to identify 0 or 1, identify the prime numbers, because I guess in the scenario for which this application was written, prime numbers are much more interesting than whether a number is even or odd. But then there's no other characteristic left, so I'm going to identify the number as either even or odd. Okay, so I suggest that with the sample code, you play with this switch statement, step through it, make sure you understand what's going on each step along the way. Because switch statement has a lot of options, a lot of flexibility, and some quirks and foibles that can trap you. But by playing with it and using it in conjunction with nested if blocks, in this case the switch was nested within an if-else block, but you can also include nested if blocks within each case. A lot of different things that you can do with the switch statement. It's very flexible.